good day, and welcome to Africa Teen Gigs Online School. Yes, this is your Physical Sciences grade 11. If you have just joined in, and my name is Nonkululeko Matondo. I am your teacher for Physical Sciences grade 11. I hope that everybody is ready and waiting to do some revision for chapter 5. Guys, it's been a long journey with this chapter 5, but slowly we managed to pull it through. And today, like I mentioned yesterday, we are going to be doing strictly revision. And guys, please don't hesitate. If you guys have a question in whatever else I'm doing, please let me know, stop me, so that I can continue and ask and respond and explain to the question. Because you know what, guys, at the end of the day, it's not about finishing a chapter, it's about understanding what has been done in the chapter. I mean, if we finish this chapter and you guys are still lost, then this teaching was not of use to anybody. So the main point with doing revision now is just to go and recall and replay everything that we've done in the previous units, which was about 8 units that we did, and we were doing 1 unit a day. So yesterday we did some summary of all the chapters, and I hope that it gave people some enlightenment, and you guys did all your homework. If you remember properly, we spoke about um, that we are working with the Oxford Successful Textbook. That's the textbook that we use in our class here on Physical Sciences Grade 11 African Teen Geek Online School. Reason being, it's better if we use one rather than using a lot of textbook and then they end up confusing us because we don't know how to follow. Each textbook has its own set of way in which they formulated the topics. So with us, we are using the successful textbook, Oxford Successful Textbook, and you can get it for free, absolutely free, for the whole year this year because of the COVID-19. You get your textbooks for free, um, and you get them from Snaplify. Snaplify is an app that you guys can download as well, and you can register. It's absolutely free. You can get all your textbooks, not just for physical sciences, but there's even other textbooks other than the Oxford Successful, there's Siavula or whatever that you want. It's all there. You guys just have to go and find it. Okay, without wasting any much time, we've got a lot of work to do, guys. Especially with this revision, there's a lot of things that we are going to be doing. If you remember properly, we spoke about the first part. There's two parts of this revision questions. And what I asked was that on the first part of the revision questions that we do the odd numbers. And then on the second part of our revision questions, we do the even numbers. So I hope that you guys didn't get confused thereby. Okay, my screen is a bit slow right now. So I just want you to check the problem. If you guys have it, uh, it's going to be going through just now. Yes, it is indeed a Friday. It's a good time for some mind tests and making sure that everything that you've done during the week has now been concluded, just like we are concluding this chapter. Next week, we're going to be continuing with chemistry part 2, and we will be doing chapter 7. Yes, I think we're going to be doing chapter 7. So you guys can follow through. You can already practice what we're going to be doing, and you guys can follow through with me once again, and we can continue making chemistry work in physical sciences. I know it can be really complicated when it comes to physics, especially if you start in a place where you didn't understand anything. Um, in our case, we've gone through each and everything. So I hope that everybody is ready. I'm just trying to get to our question. Okay. Oh, okay, our book is jammed, it seems. But nonetheless, don't you worry. Um, we will get through the questions. I think have to I might have to read the question. I might have to read the questions and just go straight to the answers because this is going to take a lot of our time having to come here, especially when the screen is jammed like it is right now. Okay. And then I will read the question for you guys. I hope that you guys have done your homework and you've done your even numbers like you promised. And we can start our revision work. I'm just sharing the screen quickly. I don't know, my internet is not doing so fast today, but it will not deter us. We are continuing with this revision today. Yes, here we are. I'm just opening up the questions on my phone. Okay, so here on the first one, they're basically asking us about, they asked us to give one term for each. So let me just get the correct words. I'm almost there, guys. Okay, here we are. Yes. Okay, it says on the first question, okay, this is the first part. This is the one where I said, can we first do the odd numbers with this first problems. So they say stoichiometric calculations with composition of substances and molar volume. That's the part that we're doing first, okay? So on number one, they say give a word or term for each of the following. So if you check there, they said give the volume of 1 mole of gas at STP. What is that? That is called the molar volume of gas. Okay, I hope you got it right. Just check your answers. The molar volume of gas is the volume of 1 mole of a gas at STP. Okay, it's called a molar volume of gas. Okay, and then 1.2, it says the name given to the number which indicates the number of particles in 1 mole of a substance. Okay, the name given to the number. So do you guys remember earlier on when we started with the Avogadro constant, which was the 6.02 times 10 to the power of 23, and that was the number which indicates the number of particles in 1 mole of a substance. So I hope you guys got that one right too. And then on 1.3, it says the name of the chemical formula that indicates the actual ratio of atoms found in a compound. Okay, yeah, the name of a chemical formula. Okay, what do we call that? We call it the relative atomic mass. Okay, because that's the name of the chemical formula that indicates the actual ratio of atoms found in a compound. Remember, this is the one where, for example, with hydrogen, it's 1.007 and it's U. The unit it's U. That is our relative atomic mass. That's the exact mass of um, atoms found in the compound. Okay, I hope that you guys got that right. Okay, so we're moving to number 3 because I hope that you guys have your questions ready. Let me just try and see if we will get our question again, which is on Snaplify. Okay, here we are. On number 3, it says that on number 3, it says 5 gram. Okay, this is the other problems. Yes. On our number 3, it says 50 gram of CaOH2 is dissolved in 200 milliliters of water. So number 1, they want us to calculate the number of moles of CaOH2 in the sample. Number 2, they want us to calculate the number of formula units of CaO2 in the sample. And number 3, the number of oxygen atoms in the sample. Number 4, they want us to calculate the concentration of the solution. Okay, so let's go back and see how we're going to work that out. This is our number 3, guys. Okay, so what do we have? What has been given to us? We've been given 50 gram of CaOH2, and been given 200 milliliters of water. And if you check, this is enough information for us to start some calculations. So what does that mean? We know the first step in calculating anything, we need to convert whatever is given to number of moles, because that's the standard unit that we calculate all our problems. Okay, so we're going to start by looking for the molar mass. As you can see here, I've calculated the molar mass, which is Ca plus 15.994 plus 1.00794 times 2. Okay, so this is a product, and then you add it to this one, and this is what you get. After that, we look for the number of moles, which is M divided by mass divided by molar mass, and that will give us 0.675. You can see here, the mass is what we got here, what was given, and the molar mass is what we got from calculating it. Remember, guys, I always remind you guys, the molar mass will never be given. You always have to calculate it. That's why it's important that you guys know your periodic table, and you always have your periodic table when you're doing any calculation, because that's where you're going to get your molar masses. And as you can see, in every calculation we get to calculate the molar masses because they are important. Okay, so number two, let me see, the second one, they asked us the number of formula units of SaOH2 in the sample. Okay, what does that mean? It means that they want the number of atoms, like how many atoms are there in this compound. So what do? We're going to use the Avogadro equation, which says N is equals to X divided by Na. X is what we're looking for. It's the number of atoms, and this is the number of moles. And Na is the Avogadro constant, which is given, which is 0.602 times 10 to the power of 23. So we make X the subject of the formula, and this is what we get. So these are the number of atoms that we have in this compound. I just forgot to say 4.067 times 10 to the power of 3 of CaOH2 atoms. Okay, so that's something else that you guys always need to remember. Okay, and then these are quite short questions. So on number 3, they say the number of oxygen atoms in CaOH2 sample. So now, first they wanted the number of atoms in the whole compound, and now they want the number of atoms of the oxygen atom alone. So how are we going to work that out? We're going to say, okay, number of atoms, it's 2 atoms. So oxygen atoms, it's going to, we add the number of moles that's given for the whole compound times the ratio of O2 and times the Avogadro constant. So that's how we find it. So NO2 is going to be 2 times 0.675, and um, that will give us 1.35. Okay, that's the number of moles of oxygen. If you guys are having a problem, just let me know. So now we go straight to looking for X. How do we find X now? We already have the N, so we can go straight to the X, which is going to give us 1.35 times 6.02 times 10 to the power of 23. And this is going to be our answer. So you see, guys, these first ones are quite simple questions. And, sometimes you can get confused when you've done so much. You feel like maybe there's something else that you're supposed to do, but don't you worry. Just focus on what you know and what you've learned. And if you do have questions, please, guys, don't hesitate. Drop me a chat and let me know where you have problems so that I can, stop where I'm at and just explain whatever it is that you need me to explain to you. Okay. I hope you guys understand the Avogadro's constant and how it operates. So now we're moving on. We're going to number 5. Remember, we're doing odd numbers. I hope that you guys are following with your answers that you guys have done, and you're getting the answers right. So we continue with number 5. On Oh no, we still have 3.4. Sorry about that. Where they ask for the concentration of the solution. So we know with the concentration of the solution, once you have the number of moles of the solution and the volume, you can get your concentration. Remember, your volume was given as 200 milliliters. Yes, I think it's 200 milliliters. Let me just check it. Yes, it's 200 milliliters. So you have to divide it by 1,000 to get your dm cubed. Okay. Yes, I hope you guys get that. And first you convert it to dm cubed, because you know with concentration in the formula, it works with dm minus 3. So we cannot use milliliters, otherwise we're going to confuse the equation. So here we're going to say n divided by v. The n is what we've already calculated of the compound. Remember, we're no longer doing oxygen, we're doing it of the compound, and we divide that by our volume, which we've just converted into dm cubed, and this is our answer. I hope you guys understand it. And if you don't hesitate. Just let me know, and I will keep. I will go back and explain to you guys. Okay. So on number 5, what they say here. Okay, let me just go back to the screen and we can see it all in case um, you don't remember the question, but I hope that everybody has done it. Yes. On number 5, it says 23 gram of NO3 gas is produced at STP. Okay. Calculate the volume that it occupies at STP. Okay. Let's just go and see how that is done. Okay. So this one is a pretty simple and straightforward question. If you've got gram, it means you can calculate the number of moles. We already have gram here, and we can calculate the number of moles. For moles, we go straight to looking for the volume at STP, because remember at STP, we've been given the Vm, which is equals to 22.4. So already you know um, the steps to this one. So what do we say? Okay, sorry about that. Okay. Okay. So we look for the molar mass of NO and NO2, and this is what we get. I always write it fully, the molar mass, so that it can sink in your mind, that you take it the way you find it on the periodic table, and you just plug it onto your equation, and you get your gram per mole. From there, now we look for the number of moles, which is 22 divided by 46.0055, and that will give us 0.5 mole of NO2, guys. Always important to write this, just to make sure that you guys are keeping track with what you are doing. Okay. From there, we go straight to the volume at STP. What is our volume at STP? Our volume at STP is N times Vm, and that will give us 0.5 times 22.4, and that will be 11.2 dm cubed. Guys, this is your chance. If you have a problem, just shout out and I'll go back and explain to you guys. But I hope that you guys understand these problems as we're doing it over here. Okay. Okay. Now we're moving on. We're going to number 7. Okay. I hope that I'm not reading too fast or going through it too fast. But I'm thinking if you are reading through what you already have, it might be a bit easier. Okay. So now we go to number 7. What do they say in number 7? They say a hydrocarbon with a molar mass of 42 gram per mole minus 1 has the following composition. Okay. We've got carbon of 85.7% and hydrogen of 14.3%. calculate the molecular formula. Guys, I hope you guys remember these problems when we did them. Number one, there's certain steps that you need to do when you're calculating the molecular formula. Number one, you need to know that these percentages that they give you here, they are your grams, because we assume that the whole composition is 100 gram. So if it's 100 gram, it means this is 85.7 gram and this is 14.3 gram. Okay, that's the first thing that we need to know. Number two, before you calculate the molecular formula, you need to find the empirical formula. Okay, those are two important factors that you need to know. You cannot just jump from what you have here and then you go straight to calculating a molecular formula. Going through a molecular formula, you need to start with the empirical formula. Okay, so now let's go to our answer. Okay, so there we have it. Okay, it says what we know here is that for the CH, we don't know how much the CH is. We don't have its formulas because they have, that's what we're looking for. Okay, so when we look for a molecular formula, guys, just quickly going back, what you're looking for, you want to know how much of your element is there in your compound. Okay, when you look for a molecular formula, that's what you're looking for. They'll just give you C and H, and we need to find the subnumerals there of how much atoms of C, how much atoms of hydrogen are there in this whole compound. So that's why molecular formulas and empirical formulas are so important, because they tell us what our compound is basically. Okay, because you know a compound is made by everything, by the atomic, by the number of atoms and the elements themselves. So all of that, it makes up a name. So now we want to find out what is this compound, because we don't know. What we have though is the molecular formula of the whole compound, but still we cannot assume what it is because we don't know how much of each is given out there. So what do we do, guys? Hence I wrote here sample is 100. We assume that the sample is 100%. So this will be our grams. Okay, then from there we go. Okay, and you say carbon. Okay, we've got our molecular moles for carbon, and we have our molecular mole for hydrogen, molecular mass, sorry about that. And then we'll look for the number of moles. I'm so sorry about this scratching out, but I hope that you guys are seeing what I'm doing. And please, guys, don't hesitate. Send me a chat if you have a problem or you don't understand something that I've just explained. Okay. So it's going to be number of moles is equals to M divided by M. And what is that going to be? It's going to be 85.7, which is this one that we converted to gram because we assume the sample is in total is 100 gram. Okay. And we divide that by the molar mass. Okay. And from there, this is our answer. Our answer is going to be 7.14 mole. Okay. Then we go to hydrogen. We're calculating both of them because here when we're looking for the molecular masses, when we look for the molecular formulas, we're working with the ratio. So it's carbon to hydrogen, carbon to hydrogen. So that's why I like writing them next to each other. Okay. So for hydrogen, we do the same thing. We say M divided by M, and this is the answer that we get. Okay. And then after that, to get the ratio of the um, empirical formula, guys, what is an empirical formula? Empirical formula is basically one atom, and then a molecule is many atoms. Okay, if you guys remember the chemistry definition. So now when we check the empirical formula, we want to find out how much is the ratio of each product on one atom. Okay, do you guys understand me? On one atom, how much do we have? So what do we do? Okay, we've got our seven. We got both numbers here. So what we do here, we divide them by the smallest number that we have here. So that would be the 7.14. If hydrogen was the smallest number, we were going to divide it by the hydrogen number. So don't think I'm dividing it because it's the one that comes in first. No, we divide both sides with the smallest number. So in this case, it's 7.14. So our ratio is going to be 1, and our ratio for this one is going to be 2. And guys, remember, even if it can give you 2.1 or 2.5, you always have to push it to the nearest whole number. So if it's 2.7, you know your ratio will be a 3. You do not write 2.7. Okay, so empirical formula. This is our empirical formula. Do you guys now see what I mean when I say that here on the empirical formula, in one atom, we want to find out how much of hydrogen is there and how much of carbon is there. So now we know it's C1H2. I hope you are following with me. And if you're not, just let me know, okay? So now we move on. Now that we have our empirical formula, now we can find the molecule. Remember, the molecule is made up of many atoms inside. So now we need to know the molecules. How many molecules are there in each? Okay. So the molecular mass. Yes, the first thing that we do, we look for the molecular mass of. It's a new one now. Remember, they've given us one before, but that one we didn't know how much of each it came from. So that is the molecular mass given. Which one am I talking about? I'm talking about this one that we have here. Remember, they gave us this 42 gram per mole. This is the molar mass that is given. But now we also have a molecular mass for the empirical formula. So here for the CH2, now we need to calculate a new molecular mass. And this is what we get. We get 14.3. So now for the molar ratio, I just wrote it out in names so that you guys can understand where each comes from. So we take the molar mass of the empirical formula, which is what we calculated here, and we ratio it against the molar mass of what is given, and we divide them both by the empirical formula. You see, so we're going to say 14.03 divided by 14.0 is going to give us 1, and then we're going to say 42 divided by 14.03 again, and this will give us a ratio of 3. So what does that mean, guys? It means that now we know what our empirical formula, our molecular formula is. And how do we work that out? We take this number here that we've just, the molar ratio, and we times each of these ones of the subnumerals by that number that we get here. In this case, it's going to be 3 times 1, and that's going to be 3. And then we're going to say 3 times 2, it's going to give us 6. So this is our molecular formula. I hope that you all understand it. And if you don't, guys, let me know, and I'll swiftly go back and explain to you guys all over again. But I hope that you guys understand how you get the molecular formula and why the molecular formula is so important. Okay, so now we're moving on. We're moving on to number 9. Okay, what are they saying in number 9? In number 9, they're saying ammonium nitrate is a common fertilizer. The effectiveness of a fertilizer is based on its nitrogen content. Okay, so 9.1, calculate the mass percentage of N in ammonia nitrate. Number 2, how many grams of N are in 35.8 kilogram of ammonium nitrate? Okay, let's just go and check out how we get to do this one. Oh, guys, we're running out of time. I think maybe on Monday when we get together again, we'll just continue and finish up the revision questions, because these questions, guys, are important. You guys need to know all of them, and I can't just skip them so that we can start a new chapter. Everything, it's all about you guys understanding. It's not about finishing the chapter in so amount of time. It's about the understanding of each and every chapter that we're going to be working with. So on number 9, first thing we do is look for the molar mass of ammonium nitrate. So this is the molecular formula. Okay. Think you understand it better now, the molecular formula. This is the molecular formula of ammonium nitrate. So we look for it, and we find the molar mass of it. And then after that, we look for the molecular mass, the molar mass of the nitrogen. Remember, there in that question, they're asking us about the nitrogen specifically. Let me just go to the question number 9. It says, calculate the mass percentage of nitrogen in ammonium nitrate. So here I multiplied it by 2. Why am I multiplying by 2, guys? Because in this molecular formula, we've got 2 nitrogens. We've got the one here in the beginning, and we also have the one here close to the end. So you must be careful of that, not to make it one because you just see NO. There's 2 because this is one molecular formula. This is one compound. So you've got 2 nitrogens in this compound. So this will give us 14.007 times 2, and this is our molecular mass. So now we're looking for the percentage of nitrogen. What are we going to do it? How do we do it? We do it, so we're going to say the molar mass of nitrogen divided by molar mass of the ammonium nitrate. So basically, we're saying 1 divided by 4. So this, what you write underneath is the whole thing, because we're looking for the percentage out of the whole compound, and that will give us 34.99%. I hope you guys understand how we got to this. And if you don't hesitate. You can just shout out, okay? So I hope you guys understand how we got this. You just take the nitrogen times by 2, and you look for both molar masses, and you divide it against each other, and then you times it by 100%. Because this here, remember, this is 100%, and this is the percentage out of this. That's why this one becomes the total, and this becomes the percentage that we're looking for. So the unknown percentage, which is N2 in this case, we're looking for how much it is in the whole compound. So on 9.2, 9.2 says, how many grams of N are in 35.8 kilogram of ammonium nitrate? So what are we going to do here? We're just going to take the percentage and times it by the 35,800. Remember, from dm to kilogram, you times it by 1,000. So we're going to say 35,800 times by this one, but now we're making it a decimal. We're going to divide it by 100 to have the decimal number of it, and then we times it by that, and this is what we get: 12,538 grams. I hope you guys understand how we got to this one, because if we know the percentage and they give us, if we know the percentage and they give us the number of ammonia, we can just take percentage out and percentage out the total. So that's what we did here. Basically, we took the total and we timed it by the percentage so that we can find out how much it actually is in grams. Okay. Yay. So now we are done with the first part of our problems. So now going forward, we don't have enough time. We've got only like 12. No, we still have we don't have time, guys. We almost have like 6 minutes left to the, maybe I can just do the first problem and then we'll continue the rest of the problems on Monday, because I know it's a Friday and you guys are tired. You've been watching the videos and doing so much homework all this time. So now we are done with the first part of the calculations that we said we're going to do. Now we're coming to the second part, which is stoichiometric calculations with concentration limiting reagents, percentage yield. This is a much longer questions now. What we did before was short questions. So we're just going to do one for today. We're going to do number 2, and then on Monday we'll continue with the other even numbers. Okay, guys, please do your homework so that you guys can follow through and know what you don't understand and know what you don't. Because if you do the problems, you're testing yourself basically. So if you don't do your homework, you are actually cheating yourself. So it's always good to do your homework and understand what is happening in each chapter. It's better when you have all the problems and you're just marking all your steps that you've done, and it makes it easier for you to be able to ask questions. So here on number 2, this is a pretty long question. I hope we'll be able to finish it in time. Okay, a fuel mixture used in the early days of rocketry is composed of 2 liquids, hydrazine N2H4 and dinitrogen tetraoxide, which ignites in contact to form nitrogen gas and water vapor. Okay, 100 gram of N2H4 reacts with 200 gram of N2O4 according to this reaction. So what do we know? When we have when we've got 2 compounds and they give us 2 grams, and after that, that gives us a product. What do you know about it? We know that we need to calculate the limiting reagent. Why? Because the limiting reagent is what you use to calculate your product. So in this case, we do not know what is our limiting reagent because they've given us 2 masses and they've given us 2 compounds. So we do not know what is a limiting reagent. So first question, as expected, they would ask us, determine the limiting reagent. Okay, I think I'll read from my phone just to try and be quick. I hope I'm not too quick and leaving you guys behind. Okay. So, yes, this is our problem. So, first we're going to look for the molar mass of the first one so that we can find the number of moles. That's always the first step. Convert what you have into moles. Okay, and then we look for the second one again. I usually like writing it on parallel on the sides, but I couldn't in this case because it's just so much, and these molecular formulas are so long. Okay, so for the second one, the N2OH, once again I looked at the mass and then calculated the number of moles. Thereafter, you know how we do it. There's many ways to calculate the of finding out which one is a limiting reagent, but I prefer to use this formula. Maybe if you get a chance on Monday, I'll show you guys the other way in which we use it because I didn't use it here. So we're gonna take the number of moles. Let me just make the screen smaller. Okay. Yes. The number of moles, remember guys, we're taking these ones here in front of our compound. So here it's 2 over 1 because here there's no number. And then we take that and it gives us a 2. So what do we know from what we've learned on limiting reagent? When we calculate the ratio of these things between the 2, we know that if the number is going to be less than 2, then our limiting reagent will be N2H4. But if it's more than 2, then it will be N2O4. So in this case, we took the molar masses, the ones that is calculated together, and this is what it gives us, 1.4356. So this is less than 2, so which means our limiting reagent is going to be N2H4. Okay, I hope you guys understand because it's less than 2. If it was more than 2, then it would have been N2O4. I hope you guys understand that part. We don't have enough time, guys. I think I must just close it down. We'll continue this problem on Monday. Guys, thank you guys so much for joining me on the show. On this class. I'm sorry about that, which is Physical Sciences Grade 11 class. Today we were doing the revision of Chapter 5, but on Monday we'll continue with our revision because, guys, it's not about getting chapters done, it's about getting the understanding done. It's all about you guys getting to know what you don't know and understanding it in time. So that's why I do not rush our program or anything. I'm going everything step by step, making sure that you guys catch along. My name is Nonkulilego Matondo, and this is African Teen Geek Online School. Hope you guys have a wonderful weekend, and please do join the Physical Sciences Grade 11 class on Monday, and we can continue. Please, guys, do your homework so that we engage. On this second part of set of the question, please do your even numbers. If you haven't done all of them, you can finish them off during the weekend, and then on Monday when we're doing the problems, you guys can ask questions where you guys get lost. This is me signing up, and thank you. Thank you.